In this video, we will learn about preparing digital elevation model using TIN, and also we will perform some DTM analysis for generating surface characteristics such as slope, aspect, and hillshade. So let's start our tutorial. I have downloaded the manual and data. You can download it from the link provided below, or by visiting the website. You can download this from this website, and you can also find the instructions in this website. Now let's extract the data. Extract all. Extract. After the files are extracted, you can see all the files inside there. Until then, let's open ArcMap. Okay, we also have the data extracted. As you can see, we have all the files in there. Now we open ArcMap, and then let's follow the instructions that you can find in the website as well. Let's go with a blank map. Now we'll add data. As you can see, there are no folder connections to that one, so I'll add a folder connection to my documents, advanced GIS. Okay, manual and data, exercise 12. From here we'll add spot heights and also the contours, both the contours. And okay, let's add that first. Also, let's add the view shed. Oh, it should be somewhere in DTM. Oh, okay, yeah, we have already added the contours and spot heights, so that should be it. Also, let's add the municipal boundary. Okay, now this is the location of Dhulikhel. Now first let's create TIN surface from spot heights and contours. That's our task 1A. For that, we can simply go to the search menu and search for create TIN. Search. This is the one we need from 3D Analyst. Okay. And where do we want to output our TIN? Yeah, let's output it here. Let me just simply create output folder, okay, for our ease. Dhulikhel, let's name it Dhulikhel TIN. Okay, save, and coordinate system, we will just put the UTM-87. Why not import it from the contour data? Okay, yeah, UTM-87, good. Okay, now let's input the features. You can input it from here, or you can just drag and drop them as well, whatever you find easy. Now just let's select the height field, because that's where we have the height information. We'll make it soft line and constrain Delaunay. Tick that and press OK, then wait for some time. As we can see here, we have the tin data. Let's move the tin above so that it can be clearly seen. Now let's create digital elevation model surface from this tin surface. For that we will search for tin to raster, and then click the 3D analyst tool. Our tin data, let's select that data and let's select our output. It's going to be Dhulikhel dim raster, right? Okay, that is what we're going to do. What error? Oh, sorry, it's longer than 13 character. So okay, this should fix the error. Now the output data, let's put it to integer. Method is linear is okay, and sampling distance 250 is fine. Z factor 1, it's okay. Now here's the important part. Go to environments, then scroll down and you'll see raster analysis. Here let's select the custom cell size. So under cell size, as specified below, and we will have 25 as the cell size. Then press OK, and that should be it. Now let's complete the processing. Okay, let me turn off the tin layer and also the other layers. Okay, now here we have our DEM, digital elevation model. This is the DEM we got. Now let's first clip the DEM with our boundary. As you can see, it's beyond our boundary. So for that we'll use the extract by mask tool. We can just search for that, extract by mask, and that's what you will see. So let's click that, and input raster will be Dhulikhel DEM. Then our mask data will be municipal boundary. Let's save that here. Dhulikhel DEM clipped, right? Yeah. Okay, I'm sorry, it's again very long. So the DEM clip. Okay, let's just name that and press OK. Then it will clip the DEM. As you can see, it's just that part. Now we can classify it. Let's classify it to 7 classes. As you can see, we have our data ranging from 1000 to 1700. So let's classify to 7 classes, and 1100, 1200, 1300, 1400, 1500, 6 13 14 15 1600 and 1700. In this way we are setting the breakpoints manually. I forgot to set it to manual, it was already manual. And you can also see the statistics. Now let's just press OK. We'll use different color ramp and this. Okay, so this looks good. It's good for visualization. Now let's perform our next work. We'll be generating slope. For that, let's go to the search. Let me clear this search, and instead now we'll search for slope. To generate slope, search for slope and use the 3D analyst tool, slope. The input raster is dem clip and the output Dolichal slope. Yeah, okay. Let's press save. Oh, it's again a long name. Okay. Let's just write dem slope. I don't know why I always like to have a very descriptive name. So okay, we'll have degree and then method. It should be okay. This should not matter. Z factor is 1, right? Now simply press OK. This is our slope data. As you can see, green means the slope is 0 to 4.4 slope, and red it means there is very steep slope here. Now next step, we will be generating aspect. That is task 3B. From search menu, let's search for aspect, and we'll select the 3D analyst aspect. The input raster will be our extracted dem, so dem clip, right? Then our output, let's just write dem aspect. Good. And that should be it. That should do it. Planner is fine. Okay, now let's press OK. This will generate the aspect, as we can see here, the aspect, and also the legends show us in which aspect each of the part is facing. It has a eastern face, and this one orange has a northeast face. So we all know how to read the legend, right? How to read the aspect. Let's now generate hillshade. Again, you can search for hillshade in search menu. Select the 3D analyst tool for hillshade. The input raster is dem dem clip, output dem hillshade, azimuth 315 is okay, and altitude will have 45. It's all okay. And next we will check the modal shadows. You can see the meaning of that as well here in the help menu. The output shaded raster considers both local illumination angles and shadows. So that's it, and then let's press OK. As you can see here, this is the hillshade shadow of like a realistic hill shaded image. Hillshade is a very useful way of displaying information in a very realistic way. As we can see, just showing the raster image, just showing the dim, that does not really show how it would look, the topography. For example, if we just see the dim, we don't know what it looks like, but hillshade is really very realistic. So we will be using this as like a base map for another thematic map on top. So let's just turn off all other layers except for the hillshade. Let me minimize this. Okay, now we will add the image. Oh, it's in manual and data, right? And let's add the image 1. Yeah. So we, by just seeing this image, we cannot really identify how the feature looks like. But if we go to property and display, then set the transparency to 50%, say about 50%, and apply. See, you can already see the difference. You can even use other images. This is the black and white one, and it's not great premise for now. And here's another one. So whatever image you use, you can use hillshade to represent that. You can even use multiple images on top of the hillshade, and that will give a 3D visualization. But as you can see, the hillshade, it's not a very sharp hillshade, and also the picture is being washed out in the white parts. So this has washed out the terrain details as well, especially at shaded areas. So the Robert Mark of US Geology Survey, he developed a technique for combining multiple weighted hillshades with different sun positions to more fully illuminate the surface. The result is a sharper hillshade that enhances the detail in the shaded areas. For that, to get the Dr. Mark's algorithm, we will import the effect. First of all, let's save our ArcGIS file. We will be saving it here. Yeah. I'll just name it DTM tutorial. Save. Now go to customize toolbars and enable the effects toolbar. Then go to customize mode and go to commands. This is important. Go to commands. Here look for special analyst in the categories. Let's see, where is it? IZKLMNOPQRS, special analyst. Now we will add from file. From the downloaded file you can go inside into the software folder, and here you have the advanced Hillshade, the DLL. Open it, press yes, okay. Here you can find the command. Now simply drag and drop it to the effects panel. So there you can see the multi-directional oblique weighted shaded relief. We have successfully imported the algorithm. Now you can just close it, and then let's see, we want to edit our hillshade. Where is our hillshade? Yeah, DTM hillshade, right? As you might have noticed, my extension is disabled. This is because I have not enabled from customize, go to extensions. I have not enabled the special analyst extension, so we have to enable that and press OK. Then you can see it's enabled. Now let's press that. Here let's select the input surface, that is our DTM hillshade, and press OK. Then it will perform some analysis, and then we can get a very sharp hillshade, right? Till this part we have created a very detailed DTM by Hillmark's algorithm. Now next we will, let's first change the name here to Hillmark. Okay, now as we can see, the DTMs are not comparable because it has different styling. The DTM generated by Dr. Mark's algorithm and the standard DTM, they cannot really be compared because they have different symbology. So we want to represent the Dr. Mark's hillshade by the same symbology that we have used for standard hillshade. But how can we do that? How can we go manually and do that? Instead, we can just copy the symbology from the standard one to the Hillmark symbology. For that, we have yet another toolbar for that, a custom tool. Let's go to customize and customize mode. For that, we first have to enable the context menu. So enable the context menu. Okay, now go to command, then in the command look for the context menu. Okay, Okay, we don't find the context menu, right? Raster layer context menu. Do we have that? Okay, we don't really have that. So let's just add to raster. Add from file. Then again, in the same place under inside software, we have copy ras sim. That is copy raster symbology. So import that. Open and press yes. Okay, done. Okay, so we have that here in the layer, right? Copy raster symbology. Now we will be dragging that inside our context menu. So go to context menu and keep dragging it. I'm dragging the command and scrolling down till I reach raster layer context menu. IJKLMNOPQNR raster layer context menu, and I'll drag it below. Zoom to raster resolution, and then I'll leave my mouse button. There we go, we have it there. Then that's it. Then we can close the context menu as well. And press close. Oh, I'm sorry, I also had to drag the paste context menu. So let's again go there and enable the context menu from commands. Was it inside layer? Yeah, under layer we have paste raster symbology. Why is it not showing the context menu? There must be some bug. Let me not do that. If you get that kind of error when you don't see anything in context menu, then you can just go there and reset and click OK. Then it should clear the error. But if you don't have error, you can now again search raster and click the layer, and you have the two new tools here. So just go to context menu and then put your mouse down there so that it will scroll down. Look for raster layer context menu. So we have GHIJ. Okay, now soon we will reach there. Raster layer context menu. Click there. Now we have already copied the copy raster symbology. Now let's drag and drop it there. Paste raster symbology. So that should be it. Once we do that, we can close this. So if we click here, now we see the copy raster symbology option. Let's copy it, and then let's click there, right click there and paste the Hillshade symbology. Paste. Now both have the same symbology, so we can compare both of these raster now. But sometimes for some cartographic applications you might want the hillshade to be softer, so that it does not intrude with the thematic layers. How can we do that? It's easier than we think. To create this style, we just have to create a normal standard hillshade like we have done before, this one, and then we'll smooth it with a neighboring function with the standard hillshade and with the elevation, and combine the smoother and with it with transparency. So first let's go to search and search for focal, then you'll get focal statistics, click there, and input raster will have the normal hillshade, so that is the damn hillshade. Let's output it. Soft, or yeah, it's more like hillshade, so hill medium, neighborhood circle, radius 4, median, and then yeah, it should be checked. Now let's run the command. Then it's now very soft. Now we'll copy and paste the styling from our hillshade, copy raster symbology, and paste symbology. Good. Now both are comparable. When we compare both the hillshades, let's use this tool to compare. Oh, hill medium, right? Yeah. So as you can see, it's very softened now. The hillshade appears blurry as focal statistics tool eliminates much of the detail. Now the next step is to weight the standard hillshade with the elevation to emphasize the higher elevations. This can be done by dividing elevation by 5 and then adding the result to standard hillshade. We'll be using map algebra for this case. So let's go to, let me just select the hand tool and pan tool, and then let's search for raster calculator. Yes, under the spatial analyst. Here we'll be writing the writing the expression. You can select it from here. So we are going to prepare a Swiss style effect for hillshade. First, let me give the parenthesis. There will have the dim, the clipped dim, divided by 5, and we'll add our hillshade data to it. Then raster, we will name it hill WT. Okay, save. Okay, done. Okay. So we have the hill WT and just the hillshade as well. Let's see both of them. As you can see, we find a difference there, right? So it's not very impressive just seeing those both at one, both here. I'm sorry, the medium and this one, it's not very impressive. But if we use both as overlaying above, if we overlay the thematic map above them, then it will be very impressive. So let's move the image to the top, and then below we'll have the medium, the blurry image, the blurry one, and then we'll have hill with calculation, and we'll disable all of those others. So from here, let's go to symbology. We have already set, let's start with the image. Let's set the symbology transparency to 55%. Okay, and hill medium, let's set it to 35%, and this one we will set it to 0%. It's already 0%. So now here we can see the map shows full Swiss style hill shading effect. In Swiss style, the terrain is less detailed and the higher elevations are brighter. This gives a really vivid effect of 3D visualization. Now in this part we'll learn how to create a profile and cross-section. For that, right click in the empty space and tick the 3D analyst to bring the 3D analyst toolbar. You can also bring that from customized toolbar and then check mark the 3D analyst. So we have the 3D analyst tool now here. First we need to have the DEM with us. So let's just hide this, and here we have, oh I'm sorry, here we have the DEM, right? So this is our DEM, our clipped one. It's just the symbology that might be confusing. So instead, if we use, it's okay. So now we need to define a route to get the profile and cross section, right? So we'll be using interpolate line, and then let's have a line that includes data from both flat surface to very steep, and from lowest to highest point, right? Let's just close it there by double clicking it. This is our route, and now we will click on the profile graph. Here you can see the alt section, right? Now then how can you change the appearance and title, legend? Just double click the profile. Here you can find various things. For example, the title, you can just write it L section, right? And project work or something, apply. So that's how you do it. You can also change other styles. You can experiment with this one. So that is how you can prepare alt section, the profile. So this is the end of our exercise for creating and working with a digital elevation model, DEM. Using this technique, you can also create DEM, hillshade, slope, aspect, and also the profile or cross section. Thank you.